Hi everybody, welcome back to Chem 121. What do we got on the calendar today? It looks like there is something due tonight. Quiz number 1 is due today, Wednesday, the 14th. That is a soft deadline, so if you need an extra day, you can just turn it in tomorrow. But tomorrow is the last call. I have set it up so that an announcement should go out around like 5 p.m., just as a reminder. Like, hey, last call, this is closing tonight, so you should get that email. In fact, let me just check to make sure it's queued. Yep, looks good. So that should post automatically tomorrow, just as a reminder. Also, you'll notice that I have added onto the screen Lab Worksheet Number One is due next week. We're going to actually talk about that right now. Because what we're going to learn today is how to do dimensional analysis and calculations to do conversions that you're going to find on the worksheet. So first, let me go to the lecture preview, because that's where my window capture is. Nothing appeared. There it is. All right, so first things first, all about lab. You're going to need to read this document right here. How to upload completed worksheets in Canvas. I'm not going to go over that because it's pretty self-explanatory. Follow the directions to download both of the forms that you need. The first one is this lab worksheet, and the second one is the Google Sheet. I'm going to open up both of those right now real quick. If I can click on it, there we go. Your worksheet is just a bunch of calculations, and there is a tutorial here for pretty much all of the math that we have done in this class, as well as some extra. And then you'll get to these questions. And so it says here, worksheet exercises. Do these questions and then answer the calculations as shown. Now, what you're going to do is, once you have the answer to the question, so 5.2 quarts to liters, you're going to do that calculation on your own. You're going to then enter the result into this table. So, for example, if you thought that the answer was 105.2 meters, you would write that, and then you would enter in the number of significant figures in the number that you wrote. So I wrote 105.2, so there are 4 sig figs in that. So that would be the answer that I would report. And then I'm going to do that for all of these problems. It's 1 point each problem, okay? If you make an error on the worksheet on either the value of the units or the sig figs, I deduct half a point. If you make 2 errors, I deduct 1 point, and so that entire row is just basically zeroed. So I grade it on a per answer basis. So make sure that you have all the value of the units and the number of sig figs for your answer correct, okay? Be very careful, because in these problems, a bunch of these are multiplication, but there are some addition in there mixed in too. And you have to be very careful about what you are doing with your formulas. Secondly, be very careful about the number of sig figs provided for each problem. For instance, this number right here, 5.2, not an exact number. That would be 2 sig figs. That will affect your answer. This number right here, 680, not an exact number. None of these are exact numbers, so be very careful. Okay? Down at the bottom, there is a statement that tells you how you will be graded on the assignment. Make sure to ask if you have any questions about the assignment and how it's done. That's really all I can think of. These problems do progressively get more and more complex. Feel free to work together with other students. You can ask me questions. I can't tell you the answers, but I can definitely guide you on the right track. So if you have your work and you photograph it and send it to me, and you're like, I keep getting the wrong answer, I think, because this number doesn't make sense, can you guide me? I could circle where your mistake is on your paper and then hand it back to you. So I could definitely do that. And you can either contact me through email or Discord. When you are done with the assignment, this document, again, how to upload complete worksheets, will tell you what to do. There is an assignment that you can upload to now. And it is right here, so you should have access to Lab Worksheet number 1, and when you click on it, there'll be, if I go into student view here, it'll look like this, and there'll be a big button that says submit. There you go, right there. Okay. All right. Let me know if you have any questions about that. All right, so the next order of business is we got to get through scientific notation, which is pretty straightforward. I think everybody knows what scientific notation is, but just in case you are a little rusty on it, we're going to do a little bit of review, and then we're going to spend pretty much the entire day doing the next section, 2.7, 2.8, and then 2.9 if we can get there. We're going to work with very, very, very big numbers in this class, and also very, very, very small numbers, because for very tiny objects like atoms, excuse me, they are extremely small, and so if I were to measure like their diameter in meters, you'd get an extremely tiny number. And by virtue of being small, if I like scoop a handful of atoms, I will get an extremely large number of them. So we're going to be dealing with both extremes. Writing out numbers like this is going to be super tedious. So what we're going to do is we're going to employ scientific notation whenever we want to, whenever it suits us. This is not required. But you can see that if you don't space out your zeros like I have done here, it becomes pretty easy to lose count of them if you're counting them from left to right. So I can count them in groups of 3, and that's easy to see that, oh, there's a 1 with 13 zeros here. But removing those spaces makes it a lot more difficult, and not everybody or every form of media does that. So using scientific notation will make managing this number a lot more trivial. On the end here, I've added a multiplier, times 10 to the 0. And what this is it's going to just count how many times we move the decimal point to the left. Every time I move the decimal to the left, that's like dividing this number 10 trillion by 10. So if I move this over one spot, it'd be like I did this to it, right? So to undo that so that this whole thing has the same value, I increase this by 1 and multiply by 10. So that these would cancel out and I would have the same value. Then I just do that for every number of spaces I move the decimal point to the left. I increment it 1 more. So let's do that. Do 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 do. Ding. And then I can write my result. Now, I'm allowed to write my result in as many decimal points as I feel is appropriate. So as written, this has 2 significant figures. But if I wanted one with 5 significant figures, I would just put more zeros after it. Or if I wanted 1 significant figure, I could just cross this out and just write 1 times 10 to the 13. So scientific notation lets us write some numbers to a degree of precision that we would otherwise not be able to. For example, if I wrote this number, but I wanted 3 significant figures, well, as written it has 2. If I put a dot after it, it has 5. None of this is going to help us. So what do? I cannot write this in standard notation. So what instead I would do is this. Now I have 3 Sig Figs, and I have a number that has the value 25,000. So scientific notation is not just for convenience in dealing with really big or small numbers. It's also to help us figure out what to do to represent numbers to the correct degree of precision with Sig Figs. So be mindful that you may have to use scientific notation where it feels weird to do it. Another example would be write the number 100 to 2 Sig Figs. Well, you hit the same problem unless you do it this way. And that seems really weird to write 100 that way, but that's the only way to write it with 2 Sig Figs. All right. This sentence, for some reason, states that there's only 1 decimal place, but that's just as written here above. It has 1 decimal place. I guess we'll just scribble this out. This is not actually needed. I don't want you to think that you have to have 1 decimal place. You can have as many as you want. All right. Now, what if you want to work with a small number? Like if you had a decimal, can you do the same thing? Well, if going left increases the exponent, going right should decrease the exponent. So we'll do that too. Boop. And there you go. So if I want to represent a really large number, I can have a positive exponent. If I want a small number, I can use a negative exponent. Hopefully you are familiar with how to use these numbers and have seen them before. So there's some examples right there. This notation on the left where we just write our number is called standard notation. So if you see a textbook problem or whatever saying, write this number in standard notation, that's what it's asking, is just write it how you normally would write it. But these two numbers have the exact same value. It's just different ways to write the same number. All right, so what I want you to do, just for practice, is I want you to take these numbers and write them in scientific notation. Now, typing that into Google or into the YouTube chat is kind of difficult. So what I'm going to recommend is that you do something like this. So if you wanted to write the number, say, 525 million, like this, that I've just typed in the chat, well, let me just type it in again so that it appears on the screen here. If you want that in scientific notation, here's what I would recommend. I would type it like this, where you have like an X to represent times, 10 to the, which is 10 with a little caret. Caret is shift and the 6 key. Yeah. And then your exponent. If your exponent is negative, you can put the negative after the caret but before the number. Okay? All right. Try typing those into chat when you have the answers, and we'll go over the results in just a moment. One more minute, we'll go over the answers. All right, let's go over these together. Oh, actually, you know what? I don't actually need to go to that screen. I could just do that from here. So what we're going to do is I'm going to just move the decimal point over 7, 8, 9, 10, 11, 12. So I'm going to have times 10 to the 12 as part of my answer, and then I could just write all of the digits that remain. So that would be my answer. 4.48794 times 10 to the 12. I should point out, I don't think that I explicitly made this clear, but there were some examples that showed this. So you can only ever have one number in front of your decimal point in scientific notation. So only one digit before the decimal. That's how you do this. That's how you do scientific notation correctly. Now, technically, you can have as many numbers or digits before the decimal point that you want to, but common practice is move the decimal point as far over as you can so that the only one number is in front of it. All right, for B, 3, 6, 9, 12, 13, 14. So I'm going to have a times 10 to the 14 in here. And then I'll just put the rest of the numbers. 3.61 times 10 to the 14. That is a lot of ocean. A square meter's not big, and the ocean's a big place. The world is very large. We're going to go the other direction here. 3, 6, 9, 10, 11. So I'm going to have a times 10 to the minus 11. And I just take the other numbers. Helium atoms are tiny. In fact, the helium atom is the tiniest atom by volume. You might think, well, wait a second. Helium's not even the first element. Why is helium smaller than hydrogen? Interesting reasons, and we'll talk about that a little bit when we get to units 7, probably. All right. There's our numbers. Any questions, let me know. Now that we've seen scientific notation, if it comes up when we're doing calculations, we can handle it. And so that's what we're going to be doing here, is we are going to be doing conversions between units. And this is a very important skill in the nursing profession, in veterinary, in dental hygiene, everything that you're administering something to another patient. I have a friend, my best friend's partner is a nurse, and he also teaches chemistry, but she, his partner, is a nurse and has to do numbers for patients and stuff all the time. And the gist of my understanding of what's happening is that the nurse determines the number and then sends it up to labs, and then the labs administers the dose or measures it out or whatever, and then sends it back to the nurse. And they check each other. So sometimes mistakes will be made and you'd be like, okay, this number seems weird. What's going on? But she has told me the number of times that Labs has reported back to her that the dosage for a person was like 10 to 100 times way too big because the conversion was done incorrectly, or pounds or kilograms was used instead of pounds, or something like that, and you get an answer that's ridiculous. So the strategy that we're going to be employing here, excuse me, is that we are going to show a method to convert from one unit to another so that we get the same answer every time. This is important because if the computer at your lab or your hospital goes down because there's a power outage or whatever, all of your patients around you are not going to just say, oh, well, it's okay if the computer's down. I don't need my life-saving medication right now. I could probably make it another hour. Like, no, nobody's ever going to say that. So being able to do this could literally save somebody's life. So it's worth investing the time. So we're going to do that today. The first thing we're going to do is we're going to take this relationship. We're going to do a little bit of algebra to prove something here, because we need to make this relationship usable for our needs. So I do need to do a little bit of algebra here, which means that, bear with me, we're going to do a little bit of an explanation. All right, I'm going to take that statement as written. I'm going to write it down over here. We know there are 1,000 grams in a kilogram. That's just a definition. What I'm going to do now is I'm going to divide both sides by 1 kilogram, which is what's written on the left here. Let me zoom this in a little bit. All right. Now, if I look at what's on this side over here, I have something divided by itself. What happens when you divide anything by itself? 7 divided by 7, or 39 divided by 39, or even A divided by A, where A is a number. A non-zero number, I should say. What happens when you divide by a number by itself? What number do you get? Yeah, there you go. You just get 1, right? So, in other words, these things cancel out, and the result that you get is 1. There's all my 1s. Okay. I must be talking from the future. I know that the stream very slowly over time gets more and more and more behind. All right, we're going to write the same statement again. And this time I'm going to divide by the term on the right here, 1,000 grams. And we would note that the 1,000 divided by 1,000 is 1, and the grams cancel out with each other too. So now I have 1 equals 1 kilogram over 1,000 grams. And now what I have shown here is that these two things equal 1. So what must be true about the two things? What relationship do these two things have? They're the same thing. Yeah, they equal each other. There you go. So what we've shown is that we could take a horizontal statement, like the one that is shown up here above, and we can change it into a vertical statement, these ones right here. Furthermore, they have a value of 1. So if I multiply something by 1, it retains its value. All I would do by multiplying these conversion factors is to change the units that are present. So when I do a conversion from like kilograms to grams, I am finding the same value, but in a different unit. And I can do that because I'm just multiplying by 1 over and over and over and over again. So whenever we do problems that ask us like, hey, I want to figure out how many grams are in this 7 kilogram watermelon or something, you can just use one of the conversion factors that we just derived. So I called these unity relationships in some text that I used before. But what we can do now is we can take this conversion that we've made and then multiply numbers by it. So for example, if I wanted to figure out how many grams were in 5 kilograms, I know the conversions for that. So I could say 1 kilogram is equal to 1,000 grams, which I can then write like this. Or I wrote too many letters there. There we go. Or I could write it like this. But what I want to do is I want to set up my units so that they cancel each other out. So if I use 5 kilograms and then I multiply by one of these terms, I'm going to pick this one because the kilograms are on the bottom here. Then what happens? Well, this kilogram cancels with this kilogram, and I get the answer 5,000 grams because it's 5 times 1,000 grams. So I can do the mathematical analysis and arithmetic to decide, or not decide, but determine the value of some quantity in a different unit. And this should be pretty straightforward because everybody would look at this and say, well, if there's 1,000 grams in a kilogram, 5 grams must be, or sorry, 5 kilograms must be 5,000 grams. You just times it by 5, right? And that's exactly what we're doing. So there's my 5. But here I'm showing you the units on how to cancel this out. So now you can do this with any other number that isn't easy and round, right? So for example, if I gave you a 6.8 kilogram bowling ball, how many grams would it weigh? Well, let's do that calculation. So I know that from my conversions on the previous page, a kilogram is equal to 1,000 grams. And again, I can put either one on top. And now I can just multiply this quantity by my conversion factor, and I will choose the one that has the units in the right spot. Well, if these kilograms right here are what I want to cancel out, I got to put it in the same spot so that this happens, right? So I'm going to pick my units with that in mind. My goal is to cancel out the units I don't want to get the units that I do want. So what should go in the crossed out space? Well, it should be this one, right? Because they have to match. And then I'll just put the other unit that's available right next to it. Since this is the only unit that's left in the calculation, that's going to be the units of my answer. And now I can plug in all the numbers based on the relationship that I selected, which was this one. So there are 1,000 grams per kilogram. And now you just punch in all the numbers. 6.8 times 1,000 divided by 1. 6,800 grams. Once you've done this conversion, the last step is to consider Sig Figs. Because remember, if we're doing multiplication, you can only have as many Sig Figs as the number in your calculation that has the fewest. So this number right here is 2 Sig Figs. And it turns out that these are exact quantities because they are a definition. Remember that anything that's metric to metric is a definition. There are 1,000 grams in a kilogram by definition. So those are exact numbers. They have an infinite number of sig figs. The one that constrains our result is the number we started with. So our answer will have 2 sig figs as well. And so 6,800 has 2 sig figs. We've done the problem correctly. So for these conversions, you're going to have to figure out the conversions that you need to get to the answer. Then once you've done that, you need to do the calculation. And finally, check your sig figs. Okay, that'll be our 3-step process. Step 1 is going to be very complicated as we go on because our problems are going to get more and more complex. This is the simplest problem that we have. But that's our goal today, is we're going to be spending today just doing conversion problems so that you get used to doing these calculations. All right, so now I'm going to give you a bowling ball. It's the same bowling ball, but I want to know its weight in milligrams. So you already know its mass in grams. I want you to convert its mass to milligrams for me, setting up the problem in the same way that I did on this, on the preview. I couldn't get my mouse to go over there. There we go. So in the same manner. So I'm going to put this question right here. And I'll leave this information up there for you in case it helps you. But remember, this time we want milligrams. So you're going to have to look up, or maybe you remember the conversion between milligrams and grams. Look that up, write it down, and then do the calculation. I'm going to give you 2 or 3 minutes to do this, and then we'll go over the answers. I'll see you in a bit. All right, one more minute and we'll go over the answer. All right, so let's follow the same strategy to get to our answer. So I'm going to just scroll down a little bit. I'm going to start this problem with the answer from the last one because I have a relationship between grams and milligrams, and that relationship is on your metric table like this. 10 to the minus 3 grams per milligram. Remember that milli and 10 to the minus 3 are the same thing, so they need to be on different sides of the equal sign. All right, so I can write that relationship in one of two ways. I can put the grams on top, or I can put the milligrams on top instead. And then we'll do the calculation. So remember, I want to get this unit to go away, so I got to put the same unit in the box so it will get canceled out, right? So there's my grams on the bottom, so we're going to do that. And then that will be the units of my answer, because that's the only unit that's left. So now let's do the numbers. So 1 milligram, 10 to the minus 3 grams. Now that's a weird place to put a decimal or a negative exponent. So don't be afraid of that. Just when you type in your calculator, use parentheses. So your calculator commands would be something like 6800 divided by parentheses. And then you would hit 1 times 10 caret negative 3. And hit enter. Now, depending on your calculator, this command may be different. So you might have 1 and then hit the button that just says EE or EXP or times 10 to the n or something like that. If you aren't sure how to use your calculator, take a picture of your calculator with your phone and then email it to me, and then I can tell you, because I've used virtually every calculator under the sun. And I can instruct you on how to enter that number. Anyway, when you do this, you get 6,800,000 milligrams. That's the mass of the bowling ball. And then finally, we would check for Sig Figs. This has 2. These are exact because it's a definition, so our answer should have 2. And it does. All right, so hopefully you feel a little bit more comfortable about doing these basic conversions. I'm going to give you a few more of these to try on this slide here. Yeah, this is what I want. There we go. Now, I have a weird unit here, centijoule. Even though this isn't a unit that you've seen before, you can answer the question all the same, because the prefixes don't really care about what the units are. So I will just tell you that a joule is a unit of heat or energy. So you can think of it as grams if you want to. Just change the word joule into grams. What I want you to do is convert from the thing that I've started you with. So here I have liters. I want you to tell me that in centiliters. Here I have kilograms. I want you to tell me that in milligrams. Notice that we have to do this one in 2 steps, because I would have to go first to grams and then to milligrams. You have to go through the base unit, which is why we did the previous problem starting with grams. Otherwise, I would have had to convert to from kilograms to grams anyway, and I've already done that. Here, you're going to just do the same thing. You're going to turn this to joules and then kilojoules. Okay? And just noting that joule is some other unit, so treat it exactly the same way. All right. So I want you to try those conversions. I'm going to give you about 5 or 6 minutes. Type your answers in as you get them, and let me know if you get stuck, because I'm just going to be sitting here and I can answer anything you need. How are we doing? Let me know. Type in your answers in the chat once you've got them. Two more minutes and we'll go over the answers. All right, let's go over these answers here. So we'll do the first two. And let me scroll this up a bit. All right, so I have a 2-liter bottle of soda, and I want to turn liters into centiliters. Well, I know that my relationship between liters and centiliters is... So centi is 10 to the minus 2. So now I can set this up such that this unit cancels out with whatever's down here. So we're going to put liters there. Centiliters is the only unit that's left. That'll be the unit of my answer. And I'm going to fill in the numbers. So 10 to the minus 2 and 1. 10 to the minus 2 and 1. And then you just type it in your calculator. You should get that. All right, for the next problem, I have 175.3 kilograms. And I need to turn kilograms into grams and then into, we're out of space, milligrams. what relationships do we have? So we know that for kilograms to grams, 1 kilogram is 1,000 grams. And I know that a milligram is 10 to the minus 3 grams. So what I could do is I could turn kilograms into grams, and then I would get some number of grams, and then I could just turn that into milligrams like this, right? Well, why do I have to actually stop here? Why can't I just skip that and just not hit enter and just do the multiplication all at once, right? Oops, not kilograms. And you totally can. So you can chain as many of these multiplications together as you want to. Because multiplication of two numbers, hitting enter and then multiplying by a third number, is like you typed them all in at once and just hit enter, right? You could try that on your calculator. Do 2 times 3 times 4, and then do 2 times 3, hit enter, it'll say 6, and then multiply that by 4, and you should get the same result. It'll be 24 each time. So, we're just going to do all our multiplication at once, get to the unit that we want, because that's what the problem is asking us, and then we can do the numbers. So I've got 1 kilogram and 1,000 grams, so 1 kilogram, 1,000 grams. 1 milligram and 10 to the minus 3 grams. Now, this number and this number don't cancel. They're not the same thing. So we'll punch it all in the calculator. And I get, that's a lot of zeros. 3, 6, 7, 8. So 1, 7, 5, 3, 0, 0, 0, 0, 0. Yeah, that's right. Okay. If I want to do scientific notation, because this number is silly, it was an 8, and then I kind of messed it up there. There we go. And then we can check for Sig Figs. I've sort of been doing that automatically. Up here, this only had one Sig Fig because of this number here. So let me just scroll that up real quick. There you go. And so this number is correct as written. So we're good. All right, let's do the last problem, and then we'll take a break here. All right, I've given you this weird unit for heat. All right, so we've got centijoule, which we need to turn into a joule, which we then need to turn into a kilojoule. Now, centi anything is just 10 to the minus 2 of that anything, right? And kilo anything is just 10 to the 3 of that anything. So we're going to treat it exactly like we've been doing all of the other prefixes. It's just this time we're using a different unit that we don't recognize. And whatever's going in this space right here, whatever we're putting prefixes in front of, you can put any unit you want there. It could be anything at all. And the metric system works. That's the beauty of the metric system. All right, so I'm going to cancel out my centijoules to get joules. And then, like I said here, we're going to cancel out joules to get kilojoules. There you go. All right, when we hit enter, we will get an answer that is in kilojoules because that is what is left over. And then we just run the numbers here. So 10 to the minus 2 joules, 1 centijoule, 1 kilojoule, 10 to the 3 joules. You should get 4.184 kilojoules. All right. Looks like most people did pretty good on that. All right, so that was how we do metric conversions. In the next section, when we get back, we're going to start doing conversions between things like meters and feet. And we're going to be referring to other tables like that. But first, we are due for a break. So let's do that. Let me get the music back up and running. So where is it? There it is. All right. I will start the timer. See you in 10 minutes. Alright, we are back. Let's wind this down. There we go. Alright, where are we? We are doing more conversions. Hooray! I told you this is all we're going to do. So, if we're going to convert between units that are not metric, then what we have to do is we have to look them up. Now, the slide says table 2.2. So if you have your textbook handy, and you go to table 2.2. In fact, I have the textbook handy. Let me go get it real quick. Sorry, I'm shouting across the room here. So I have the textbook. Let me put my headset back on here. And if you have the 7th edition... Oh, I have the 5th edition. Oh, man, my textbook's ancient. It is in section... At least in this edition... It's right before 2.8. It's table 2.2. It should be this yellow table, and it has length, mass, and volume. And it's just a bunch of generic conversions between metric to English. Now, the other thing that you can do is you could just go to Google, and you could type this in and ask it yourself, like, what conversion you want to do. Now, avoid doing this for the problem that you are working on, because you totally can. If you type in 150 kilograms to pounds, Google will tell you the answer. But that's not going to help you on my quizzes when I ask you to do stuff that isn't pounds or kilograms, and I make up these fictitious units. So, I'm going to go to Google, and let's see here. 1 kilogram to pound. And what this looks like, once you've typed it in, you can just type this straight into your search bar. It'll look like this. This thing right here, this is what we want. And so now we have a conversion that we can write down. So I'm going to just shove this to the top here. And we'll write that right here. 1 kilogram equals 2.205 pounds. Oops, I was a little off there. There we go. So now we don't need this anymore. Now we can go over to here. We'll just have our orc hanging out there. I actually own that figurine, which is why I used that picture when I made this slide like 10 years ago. He's just hanging out in the living room. Alright, so I have a mass of 150 kilograms. I know that my relationship is 1 kilogram equals 2.205 pounds. Well, if I'm going to go from kilograms to pounds, same strategy applies. I want to cancel this out, so something's got to get canceled right here. We'll turn it into pounds. And then I just put in the numbers. So it was 1 kilogram, 2.205 pounds. I times those together. And my calculator gives me 330.75 pounds. And then the last step is always check for Sig Figs. This number as written has 2 Sig Figs. Just the 1 and the 5. There's no decimal point, so that 0 is a placeholder. This is 4 Sig Figs, and this is infinite. Oops. Whenever you see a conversion between two systems, one of the numbers is going to have a 1. The 1 is the exact, and the other one is an approximation. So in exactly 1 kilogram, there are about 2.205 pounds. The kilogram is the scale we're measuring against, and then the pounds is just like, oh, how many are there on there? We get the approximation that way. So my answer can only have 2 Sig Figs because of this 2 right here. And so I report the answer is 330 pounds. There you go. So you're going to have to look up some of the conversions for this. Obviously, do the calculation and do the long the cancellation and the dimensional analysis, because we're going to be working with units that don't exist later on, just as practice. And then we're also going to be doing problems that you can't look up in Google because they're just too complex. So, like, if I eat 70, like, I don't know, if I eat 7 jelly beans every hour, how many jelly beans would I eat by the time I am 44? Like, I'm currently 37. Like, that sort of problem you can't just type into Google because you have to actually sit down and do the calculation. There we go. Boop, 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 boop. All right. So, here are some more conversion problems for you to try, which you're going to have to look up the conversions for because they are all going to start in one or the other type of unit. So either imperial or metric. And you'll have to go to the other one that's requested. So the first problem is pounds to kilograms. So you'll have to look up how many pounds are in a kilogram. Well, we just did that, so you have that number. But how many miles are in how many kilometers? How many liters are in how many gallons? These will be things you just have to look up in the table, in your textbook, or by using Google. Okay, so go ahead and try these problems. I'll give you about 6 minutes. We'll go over the answers together at the end. 1 or 2 more minutes, we'll go over the answers. All right, let's go over the answers here. So first we need to know, what value are we starting with? We're starting with 579 pounds. We need to turn pounds into kilograms. And the conversion that we have for pounds to kilograms, so if I look this up on Google, 1 kilogram is 2.205 pounds. Now, you could look this up and get a different result. You could get 1 pound is like point something kilograms. 0.4536 or something like that. Either conversion works. Get the same result no matter what. I got to cancel out this unit with whatever goes down here, so we're going to put pounds down there. I should put the little S on here to be consistent. I don't think the S is actually part of the unit, but I do it anyway. We're going to turn that into kilograms. Now we run the numbers. So 1 kilogram, 2.205 pounds. Just put it in the same spot with the matching unit. And I get 262.585. 034. That's enough digits, because now we're going to go check Sig Figs. This number is written as 3. This number has 4. Ones are always infinite. Don't worry about the ones. This is the smallest one. My answer should have that many. There you go. That's the mass of my motorcycle, and when you tip it over, you can feel it. Fortunately, I've only tipped my motorcycle over like 4 times. Twice when I first got it, I believe. And then not very frequently after that. Hey, remember when we used to like drive to work? Some of you probably still drive to work, but obviously I don't, because otherwise I'd be staying in front of you doing these problems instead of being this mysterious voice coming through your speakers or your headset. So, anyway, when I drove to work, this is how many miles I went. And yeah, I would ride my Harley year round, and now I don't have to. I have a Jeep, but now I can't drive because I don't have anywhere to go. So I need to look up the conversion between miles and kilometers, and when I did that, I got this. So 1 mile is 1.609 kilometers. I believe that that's right. I'm actually doing that from memory. 1 mile, 2 kilometers. 1.60934. Good. All right, same sort of strategy. I got to get rid of this one. What's going to go here? It's the same thing. All right, that's going to give me kilometers as my answer, so let's do the numbers. 1 mile, 1.609 kilometers. 24.9395. Then we got to check for Sig Figs. This is 3. This is 4. This is infinite. Don't worry about it. 3 is the lowest. Our answer will have 3. All right. Now, when you're using your numbers from Google, I try and just use at least 4. But if you're using the Google conversions and you're writing down all the numbers, so if you did 1.60934, totally fine. Use at least 4 sig figs from your conversions on Google. I think the lab directs you to use at least 3. More is better. All right. A soda has 2 liters in it. How many gallons is that? Well, I got to look up liters to gallons because that one I don't know. So we got 2 liters, and I need to go from liters to gallons. And it's like 3.7 something. 1 liter to gallon. Oops, I want 1 gallon to liter, actually. Yeah, 3.785 liters is 1 gallon. And by now, hopefully you have the idea how we're setting up these units, because we're just canceling them out like always. And now I just run the numbers. 3.785 liters, 1 gallon. I get that many gallons. Now I gotta check for sig figs. This is 4 sig figs. This is infinite. Interestingly, this 2 is not counted. This is just 1 sig fig. In fact, interestingly, if you went and measured how much soda is in your 2-liter bottles, it just rounds to 2. That's why they write 2 and not 2.0, right? So this answer is only going to have 1 sig fig in it, and you should report 0.5 gallons. All right, there you go. Looks like people are doing pretty good on these. So let's move on to more difficult stuff. So if I have conversions that are longer and longer and longer, you can see that I'm using this sort of idea on the side here, over here, where I'm drawing out like the trajectory of my units. So this is called the unit map. So I've been already using it so that when we got to this point, you'd be all right. Can you just put decimal point 5? Yeah, that's fine. You don't need the leading 0. I don't think Canvas will ask for that. It will interpret it correctly. Well, you don't want to put as 0.5 and then any numbers after that. So the strategy here when you're trying to figure out how to solve these problems is that you want to map out your units by using the little flowchart that I've been doing over there, and then list your conversions next to it so you have them handy. Now, this is going to help you because some problems are going to require you to do a conversion between 2 different types of units. One of these problems that we're going to do is we're going to convert distance to time using speed. How long does it take me to drive a certain distance? And then we're going to start doing it with medication. How much food does this puppy eat? And how much medicine do you give this cat based on its weight? Stuff like that. So those are the problems that we're going to be doing to acclimate to these types of calculations. All right. So here's the first example. How many hours are in 2 years? Now, in order to solve this problem, you would need to make a blueprint along the following lines. So I'm starting with 2 years. So years. And I need to get to hours. I don't know how many hours are in a year. But I do know how many hours are in a day. And I do know how many days are in a year. Right? So if I do this, I can connect the 2, and then I can do the calculation. So now I can write the relationships here. In 1 year, there are 365.25 days. I'm using that because I don't know if the year I'm looking at is a leap year or not, or if a leap year is in those 2 years. So best to just take the average of a year. And then down here, there are 24 hours in one day. So now I have my two relationships to get years to hours, and I can set up my calculation like that. The same process applies. I don't want years up here anymore, so I got to cancel something else out here. What did we connect it to? Well, we connected it to days. And then I don't want days. I want to cancel it out with something down here, so we'll do that. That will tell me how many hours there are in 2 years, because that's the unit that we want. Now we run the numbers. That many days in a year, that many hours in a day. And my calculator gave me that many hours. Now I just gotta check for Sig Figs. This has 2 Sig Figs. This is 5. Exact. This is counted, and by definition, the day is 24 hours, so this is also exact. So this is what limits our calculation. And there's the answer. So how many hours are in 2.0 years? 18,000. Not exactly 2 years, because that requires us to change how we state the question. I wrote 2.0. All right. Now my slide's going to pop up with the strategy here, and then there's the answer. So I want you to try and apply this strategy to this next problem, where I give you all the conversions that you need. Well, I give you most of them, actually. You'll have to get one more to do this, but I drive my motorcycle at a speed of 75 miles per hour down the highway. It's a constant speed. It doesn't change. How many minutes will it take me to drive 20 miles? So find the number that is the starting amount, then use the relationships to get from that starting amount to the end. And you'll notice that we're going from a distance to a time here. So you're going to need something that converts distance to time, and that relationship is given to you in the problem. How will that help you? I'm going to let you puzzle it out for about 4 or 5 minutes here. And then I'll go over the answer and show you what you should do. How are we doing? Any questions? One more minute, we'll go over the answers. All right, let's show how we do this. So, I'm going to go some distance of miles, and I need to figure out how many minutes that takes me to get there. Now, miles is a distance, and minutes is a time. So in order to convert a distance to a time, because they're different dimensions, I need some sort of relationship between them. And that relationship is given in the problem. So if I know the number of miles I travel, I also know the number of hours I travel, which is a time. And if I know the number of hours there are, I know the number of minutes, because I just times it by 60, right? So let's write the relationships here. So for every hour that goes by, we travel 75 miles. That's what this is saying, right? And for every hour that goes by, 60 minutes pass. So now I have the relationships that I need to solve the problem. And we do it the same way we did it before. I don't want this unit, so something's got to get canceled out down here. It's just that now I'm setting up with this relationship that's very different. And then I can turn hours into minutes the same way to be able to solve the problem. So let's go fill in the numbers. There are 75 miles in 1 hour if we're going at this speed. And there are 60 minutes in an hour. And when I do the math, I get that. And everyone's probably like, oh no, Sig Figs, but don't worry, because this has 3 Sig Figs in it. But notice that this has 2 Sig Figs in it. This is exact. So is this one. And so is this one. So sometimes your conversions will control the number of Sig Figs in your answer. So be mindful. Look at all the numbers that are given to you so that you are getting the correct number of Sig Figs for your result at the end. So 16 is the correct answer. Very good. All right, we got 2 more problems to do before we call it a day. This is Scoots. Scoots is a puppy. And Scoots eats 65.3 grams of kibble every day. How much will he have eaten in pounds after 35 weeks? So we have, this is how long we want to calculate how much food he's eating for. And then we have this relationship, 65.3 grams of kibble every day. How do you use those two numbers to solve the problem? I'm going to let you figure it out. 5 more minutes. Good luck. We're all counting on you. Scoots is counting on you. Don't buy him too few. If you buy him too little food, he will starve. And you wouldn't want him to starve, would you? That would be bad. All right, one more minute. We'll go over the answer. All right. Oh, there he is. Here's our buffer. All right, so we got to make him really tiny here. All right, so we got to feed Scoots. Scoots, he's a hungry, growing pupper. And he eats 65.3 grams of kibble every day. So we want to figure out how much he will eat in 35 weeks. And we want to do pounds of food. Okay. Well, I know how much he eats per day. So if I knew the number of days, that would get me somewhere. So we're going to do that first. And if I know the number of days, I know how many grams of food he's eaten because each day is 65.3 grams. And then grams to pounds is trivial. We can do that, no problem. So let's write out our relationships. In a week, there are 7 days. In a day, he gets to have 65.3 grams of food. And in a pound of food, there are 453.6 grams, which you can get that one from Google. Let's do the conversion. So 35 weeks. Again, cancel, cancel. So weeks into days. Now I can figure out how much food he gets per day and then turn grams into pounds. All right, we got it all set up. Let's run the numbers. So 7 days in a week. Boop, boop. 65.3 grams per day for that one. And then this one down here. 1 pound is 453.6 grams. And I think the answer that you get is like 35.2 or something. But then when we sig fig it, it becomes 35. Yeah, 35.27. But the number that we started with is only 2 sig figs, because even though you would think you can count weeks, we're technically measuring it, right? Because it might be, it's not going to be exactly 35 weeks to the second. There's going to be a little bit of variance there. So we need to be a little more specific. This is exact because these are counted. This is 3 sig figs. And this is 4 sig figs. And the ones, we know ones are exact, so. So our result should have 2 sig figs. And there's the answer we should report. 35 pounds. Excuse me. All right. That's all the time that we really have. I was going to give you one more problem here with Hazel. Because Hazel is adorable. And then I think I have more problems for you to try here on the back here. So I'm going to leave these 4 problems for you to solve. We'll pick up next week with the Hazel problem, and then I'll post the answers to these. These are just more problems for you to practice. And then here's the practice that I want you to actually do at the bottom here. So over the weekend, make sure that you are doing these types of problems because chapter 2 is going to be full of them. And then also your lab, this is the entire point of your lab is to do these types of conversions, okay? All right, that's all we got. There's not really much to say other than assignments are coming up. Yeah, isn't Hazel adorable? Hazel was the name of my first calico cat. She lived to be 22, which is ancient in cat years, but Hazel's the best. Yeah, so make sure you get that quiz number 1 in tonight or tomorrow if you need that extra day. Lab worksheet number 1 will be due next weekend. Otherwise, the only thing that you are expected to do, besides practicing your dimensional analysis problems, is go out and enjoy the sun. It's going to be a wonderful next few days. Have a good weekend.